welcome to the last 2 days out of 3 of KVM Forum 2019. I'm Paolo Bonzini, I'm the upstream KVM maintainer. I'm not alone in this, but I'm the one that will be giving the update on KVM this year. So last year, KVM Forum was also held in October, so Linux 4.14 was released in 2017 in November. And we are going to have, actually we already had 4.19 last Sunday. So pretty much 1 year between the two conferences with 5 releases of Linux, and we already are heading towards the 6th release with the merge window currently in progress. The rhythm of development, the pace of development is pretty much the same as last year. KVM is still growing, but it's like not growing in speed, which is a good thing because it's mature software. It's there's still lots of work to do, but it's something that should also be stable. So we have about 1,200 commits from 150 authors. And employers are always difficult to compute exactly because people use their personal accounts or their university accounts or whatever. But at least 15 companies have contributed their employees' work to KVM. You can see that the number of commits in each release goes a bit up and down. Some releases have lots of work for maybe just because the stars line and all architectures put their work together in 4.16. Other releases are a bit more calm, like 4.18, but usually we're hovering around 200 commits per release. So who contributes these commits? Basically 3 categories. Hardware vendors, hypervisor vendors, cloud vendors. Of course, hardware vendors want to make KVM better for their processors. Hypervisor vendors want to make KVM better for their products. And cloud vendors actually have 2 subgroups. One subgroup is basically cloud vendors that are using KVM for their as their hypervisor. And that includes Amazon, Google, Tencent, ZTE, and there are many other cloud vendors that use KVM usually together with OpenStack or with their custom stack as their hypervisor. The other group is basically just Microsoft. I'm serious, because Microsoft is using Hyper-V on Azure, but a lot of Azure VMs are running Linux, and Azure supports also nested virtualization. Google supports it on KVM, Microsoft supports it on Hyper-V, and they want KVM to work well when nested under Hyper-V. So they have their own paravirtualization techniques, which they call enlightenments. And we've been working on adding more and more enlightenments to x86 KVM. I will go back to this topic later. So you can see that if you look at the employers, the lion's share is the processor manufacturers. Red Hat, of course, contributes a lot, both for x86 and for other architectures. And then there's Intel, Oracle, Google, Tencent, AMD, and a pretty long tail of commits from other companies. Many of these are sometimes also global changes throughout the Linux kernel, and of course they also affect KVM. If you look at the architecture, a lot of changes to x86 this year. Last year the top architecture by commits was ARM. This year it's x86. You can see that IBM contributing both to PPC and S390 has quite a few commits as well, and that's why IBM was basically number 2 in this other chart. MIPS this year had basically no activity. All those 11 commits are actually 3 wide changes, but it's still active and used and supported in QEMU, and it's not like dead code, or it's not bitrotting. So it's okay. They don't have work to do. Good for them. And so let's look at the highlights for this year. On x86, we had lots and lots of work on nested virtualization for Intel with cleanups, bug fixes, support for live migration, support for nested virtualization, so VMCS shadowing in the L1 hypervisor. AMD contributed to the support for their encrypted virtualization technology. And we added lots of power virtualization, both KVM specific for TLB shutdown and APIs, contributed by Tencent. And Microsoft, as I said before, contributed Hyper-V enlightenments. Regarding nested virtualization, a lot of the experience from this year will be also in a talk later today. And also we had these speculative execution vulnerabilities, which nobody would have expected last year, but actually some people knew already about last year. And an interesting outcome, besides fixing the vulnerabilities, is that we got support for specifying CPU features, not just through CPU ID bits, but also through MSRs. And this was a useful feature, was on the to-do list for a while, but now we had a very good reason to do it finally. ARM actually just went and optimized all the things. If you look at all the commits, the merge commits and the pull requests, it's just optimizations and bug fixes, optimization, bug fixes, optimization, bug fixes through all the releases, basically, but also support for the new interrupt controller, version 4, Geek v4, and also RAS. RAS stands for reliability, something, and serviceability. Reliability, availability, and serviceability, so machine checks and that kind of things that shouldn't happen, but when you happen, you should report it to the guest if it happens to the guest, so that the guest can handle it properly. Power got more support for Power 9, nested virtualization for them as well, which is kind of interesting because they had to basically para-virtualize it because of the way the processor works, and also they had Spectre and Meltdown. For S390, exitless interrupts, more or less the same thing as for those of you that are familiar with x86 posted interrupts. Last year they had nested virtualization and they have improved on it. They have acceleration of the cryptographic accelerator in the host. You can use it in the guest through VFIO IP, which needs some support from KVM as well. And also initial support for host large pages, which are a bit tricky on S390 due to the way the hypervisor works. And also, of course, they had Spectre v2 who didn't. So let's go back to nested virtualization. Last year, there was already a talk talking about nested VMX's performance, and it pointed out some unnecessary operation that were being done on every VM exit, so we removed them according to the indications of the talk. There was also very good work on scaling the shadow paging, especially at VM exit time between switches between L2 and L1. The MMU spin lock was really hit heavily, and as a result, even for like 4 vCPUs, you could have like 4 times slower VM exits, which is pretty much gone. It's like now like maybe 20% slower or something like that, but totally bearable. Another one is event injections. So what happens if you have to inject an interrupt in the L2 guest, but that interrupt maybe has to be serviced by the L1 guest, or maybe you inject the interrupt, but you find out that in order to inject the interrupt, you have to take a page fault because the interrupt handler isn't there, or stuff like that. Lots of fixes in this area, and the good side of this was that not only we have fixed bugs, but everybody understands the event injection better, and it's a tricky mechanism, and now it's more understood and also cleaner code. Live migration support for the L1 guest has 2 sides. One is reporting the host capabilities for VMX, because those are stored in MSRs, not in CPU ID bits, and if you have your host capabilities in MSR, user space cannot read it because reading an MSR is a privileged operation. So the new support for MSR-based features also helped a lot for live migration support. This way you can actually know to which hosts you can live migrate your host. And of course, once you know to where you have to migrate it, you have to save and restore the nested virtualization state. This took a while. It was contributed by Google and never committed, contributed by Amazon and never committed, and now finally contributed by Oracle, and with some help from Red Hat, committed. So a nice cooperation and the group work. And also this teaches you that if somebody submitted a patch and didn't follow up on it, but you are interested, pick up the work, finish it, and it will be done. Maybe for whatever reason the original submitter moved on. For now, all this work on nested virtualization is Intel only, but it's not, doesn't have to be. Just nobody wrote the code for AMD, but it's possible to bring all the improvements also to AMD. Now, last topic is testing. Of course, we have KVM unit tests, beloved repository with lots of new tests, especially nested virtualization tests across 180 commits in the last year. But we also have the API self-tests. They are new in 4.17, but they already have support for both x86 and ARM. So S390 and PowerPC guys, come on. The API self-tests have guests that run outside of QEMU. So you can actually determine precisely what APIs are invoked, testing the corner cases, testing race conditions, and they were contributed again by Google and picked up by Red Hat. For example, the API self-tests allow testing nested virtualization save and restore without having support for that in QEMU, and also testing various phases of the VMX initialization and saying that you can do the save and restore precisely at all of these phases. And it would be hard to do with just continuous live migration of a QEMU guest. It doesn't allow to test anything as easily. Sometimes things are easier to test with KVM unit tests, but there are cases like, again, race conditions, for example, where the API self-tests are really life-saving. There were some old API tests in KVM unit tests, and we're probably going to convert them to the new framework soon. The new framework lives in the linux.git repository, which makes sense because they're essentially unit tests for code really just in Linux, not half Linux, half QEMU. So you can find them there, and if you want to contribute more tests, you're done. You're welcome. I'm done, don't worry, Lucas. So.